Hello everyone, welcome back to my channel. So today in this video we'll be solving a problem based on the ROC curves and the AUC curves. So we'll see first what is ROC and AUC curves are. So ROC basically stands for receiver operating characteristic curve, and it's basically used for the graphical approach for displaying the trade-off between false positive and true positive rates. Means when you have a ROC curve, on the x-axis you will basically have the false positive rates, and on the y-axis you have the true positive rates. So likewise we solve this problem. So we have this problem saying that evaluate the performance of two classifier models. So we have two models, that is we have M1 and M2, and the table below shows the posterior probabilities for the positive class. That is this table, that is this one, shows the posterior probabilities for the positive class obtained by applying the models to the test set. Now we need to plot the ROC curve for both the models M1 and M2, and also we need to calculate the AUC. AUC is basically the area under the ROC curve lies, so that is AUC, and we need to explain which model is better. So we need to give a justification based on some judgments, like which model is better, that is M1, M2. Suppose for M1 we employed the regression, and for M2 we have the random forest. So basically just a distinguishing factor, just which model is better upon the calculation of both ROC and AUC. So we have this instances. So we have these instances from 1 to 10, and we have their true classes. So this is positive and negative classes, and we have this posterior probability for positive class for M1, that is these are the values, and next we have the posterior probabilities for M2, and so we have 10 values. So now we shall begin by constructing a table. So first of all we'll construct this big table. So this is for model M1. So we have this table. So in this we have this prediction class, that is the class which will predict. Next we will have the true class, then we will have the threshold. Threshold means the posterior probability values. Then we have the true positive, then we have the false positive, true negative, false negative, then we have the false positive rate, which is given by Fp upon Fp plus Tn, and then we have the true positive rates, which is given by Tp upon Tp plus Fn. So first what we shall do is, since we have this probability values in this way, first what we do is we just arrange into the ascending order, that is from the smaller to the bigger number. So we have 0.05, then 15, 0.30, 35, 40, 45, 0.6, 65, 0.7 and 0.8. Then accordingly we'll just arrange the true class labels of all this. You can just tally with the question, and then step 3 is just doing the prediction. Now here what we will do is we will just consider a random threshold. Say we just consider this one, that is 0.40. Why? Because it will give a better trade-off between false positive and true positive. Like this threshold selection is majorly dependent upon the business logic. So if you want to have like various business decisions are there, so accordingly you can change this threshold. So there is no hard and fast rule that you have to select or you have to decide upon this value or that value. So it's purely dependent on the business logic. So based upon this we'll just do the prediction. So this prediction is done like if you have values that is less than 0.40, that is less than this threshold, we assign as the negative class, and if we have values greater than 0.40, then we'll assign it as a positive class. So as you can see, for 0.05 we have negative class, which is less than 40. Then for 15 we have negative, for 30 we have negative, for 0.35 we have negative, and for 40 that is greater than or equal to, we'll assign it as positive class. So for all values we have positive class. Next what we do is that is on the step 4 we'll just construct the TP, FP, TN and Fn tables. So initially we begin with TP is equal to FP, that is we'll assign some of our 5 instances to true positive classes and some of the other instances to false positive, that is we'll classify some as correctly and then we'll misclassify some of the labels. So we have this Tn and Fn as 0 0 and we calculate FPR by this formula and we get 1 and 1 as the coordinates. Now this coordinates or this column, these two columns are mainly used for the ROC curve plotting, so that we'll see later. So first in this, what is the rule is that you need to check the threshold of or threshold label of the previous class, and accordingly if you have the label of the previous class as negative, then what you do is you decrement the FP count and you just let the TP count as it is. And if you have the previous class label as positive, then what you do is you decrement the TP value and you just let the value as it is as for FP. Now I'll just explain this. So we have this initialization, that is 5 5. So we have to predict the TP, FP, Tn, Fn of 0.15. So what we do is we just compare with the label of the previous threshold, that is this one. So we need to check the true class label. So if this is negative, what we do is we decrement the TP and we just increment this 0 to 1 and we let TP and Fn as it is, like it was there before. Next we need to predict for this. So for this the previous class label is negative, so we just copy this value as it is, then we'll just decrement the FP count and increment the Tn by 1. Similarly for this we have for the previous as the true class negative, so we put the values here and here as same, and then this value is decremented, this value is incremented. But for this, that is at the threshold, similarly we have the same, that is negative, we just decrement this, we increment this, we keep it as it is. Now when we move on to, that is 0.45, we can see the label is positive, that is of the previous instance of the previous threshold. So what we do is we just keep the FP and Tn as it is, we just decrement this 5 by -1, that is we'll decrement it by 1 unit and we'll increment, that is Fn by 1. Similarly for this, that is positive, what we do is we keep as it is, so this value it remains as it is and this value becomes negative, and here we'll just increment. For this what we have, that is previous class label is negative, so we'll just keep this value as it is, we decrement this one, that is 1 -1 0 and 4 -1, that is 5. Next we have for 0.7, similarly these two values are kept and this value are decremented and this value is incremented by 1. Next for 0.8 we have the previous as positive, so this two remains the same, this is decremented and this is incremented. Now we need to reach to a what I can say, it's a focal point where we have to draw the curve. So for that we need to converge these two, all these points. So initially we had the configuration 5 5 0 0, so we need to converge it to some point. So for that we need this threshold, that is 0.9. So you can see in the test instance we have only, that is 10, we don't have any 11 threshold, so we just consider this for the convergence. So if we consider this, then we can say that our graph will be converging or there would be no conversion point in our graph. So for that purpose we considered this 0.9. So 0.9, just see the true label of the previous instance, and this value is decremented, this value is incremented, and these two remain the same. And then you calculate the FPR and TPR, so that is a math part, that is very easy. And this is for model M1. Then for model M2 you again need to do the calculation, that is we have a different set of thresholds. So this is the threshold for model 2. So this value again we have to start from this, that is we need to arrange from small to big. Then comes the true class, accordingly you need to update the true class then the predicted class. So here the predicted class is this one. So this is the threshold that we have kept. So this is our choice if we want to like, it's dependent on what parameter we want to maximize or minimize. So it's like entirely dependent upon the TPR or FPR, for what values we need to have the TPR or FPR at a good count. So it's dependent on that. So similarly we get some negative instances and some positive instances, and so we can see that this one is incorrectly classified. We have this one that is incorrectly classified, that this one is incorrectly classified. So there are many other instances also which are incorrectly classified. So similarly we just construct this table. So this logic remains the same as I've discussed previously, and then we calculate the FPR and TPR. Now we have basically two curves from model M1 and model M2. So with that we'll just construct this graph. So this graph is basically ROC. So this basically, that is the blue one, basically talks about the M1 model, and this one talks about the M2 model. So on the y-axis we have the true positive rates, and on the x-axis we have the false positive rates. So all these value we can see it's from a scale of 0 to 1.2. So this we have calculated based upon our the TPR and FPR. So accordingly we'll just plot each of the points corresponding to our values we obtained from the table from TPR and FPR. Now this is the ROC curve that we have drawn. Now one thing is that we need to calculate the AUC, that is the area under the curve. So that is also very easy. So for that what we need to do is we need to just analyze each of this curve. So first let us start with this curve. So this one, as you can see, so its area just expands from this portion, that is this entire thing, till here. Okay, so this you can see there is no line in between, so we can draw a construction line like something like this. So what you have obtained is basically a rectangle one like this, and you have some rectangle or square shape like this. So we need to calculate the area under this curve, means for this much part we need to calculate the area. So first what we do is we just span some area on the horizontal axis, and accordingly we span some area on the vertical axis. So for this, that is this curve, that is for M2, what we have is we span from this much area. So this rectangle is only this much. So on the x-axis, that is 0.6 minus 0.2, that is, this is the length of this rectangle. Then for the breadth we have this portion. So we cannot calculate from here, so we need to calculate from here. So that is, this is the length into breadth will be 0.4 minus 0. Plus we have one more rectangle like this. So for that we need to calculate from, that is 1 minus 0.6, that is the length, multiplied by this much area. So that area corresponds to here. So that is 0.6 minus 0. That is, we have x2 minus x1 into y2 minus y1. So when we calculate this, we have 0.4 plus this will be 0.4 into 0.6. So this value comes out to be 0.4, that is, this is 0.16 plus this is 0.24. So we have this value for, so this is the area under the curve for model M2. Now similarly we need to calculate the area under the curve for this model, that is this M1. So that is also in the similar way. So we need to calculate the area under this. So this is one rectangle that we can get, and this big rectangle, so it's from this much till here. So similarly we do, so we need to calculate first this. So AUC for model M1 is equal to, so we need to first span on the horizontal axis, that is we have 0.2 minus 0, that is, it is this part, right? So in rectangle all the sides are equal, like opposite sides are equal. So we have 0.2 minus 0, that is the length, and for the breadth what we have is this one, that is 0.6 minus 0. So we have 0.6 minus 0. Next rectangle is this big rectangle. So this big rectangle spans from 1 to 0.2. So this is the point or the cutting point where you can say. So we just draw a construction line here and we draw construction line here. And so what we have is 1 minus 0.2, that is this 1 minus 0.2 and multiplied by the area. So we have this x-axis, now we need to have the y-axis. So that is from this 1 till this point. So this is here, that is 0 to 1. So we have 1 minus 0. So what we have is 0.2 into 0.6 plus 0.8 for this value into 1. So for this what we have is, that is 0.92. Now there is some remarks. So we need to know which value is good or which model is better. So it said that AUC is one for a perfect classifier for which all positives comes after all negative. Means in the data set, if we have all positive values on the top and then after that all negative value comes, for that the AUC is 1, means that is a perfect classifier. Else, if the true class labels are ordered in a random fashion, then we can say that it's randomly ordered. Or if all negative classes come before all the positive classes, so then we can say that AUC for that is 0. So AUC lies in the range between 0 to 1. So it basically belongs in this domain, means it can vary anything between this. So but it cannot fall between or it cannot fall below 0.5. Like since we can see this fell below 0.5, that is 0.4. So this is not a good classifier, and so we decide like this is near to 1, right? So that is 0.92. So we say that this classifier is better than any other. So this was all about solving a problem based on the ROC and AUC analysis. So hope you enjoyed this video. If you are educated watching this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.